Right, guys, we're on to the final part of this topic now, the electromagnetic spectrum. You're going to need something to write with, something to write on, and your attention span. Pause on all of the retrieval slides, have a go at them, then play it to see your answers and check them. When you're having a go at independent practice, rewind and rewatch the explanation as much or as little as you need to. Let's get going. It's a little more abstract and a bit harder to imagine. So far we've been talking about, especially with kind of sound, is an example of particles oscillating and moving side to side or back and forth. But with the electromagnetic spectrum, as the clue's in the name there, we're no longer talking about oscillations of a particle, but oscillations in electric and magnetic fields, or the electromagnetic field. Okay, don't worry, you don't need to be able to imagine it or know what it looks like. Okay, it's hard to visualize, but it's something we know a lot about and can talk about in a lot of detail and use, as we'll see. So electromagnetic waves, those oscillations in the electric and magnetic fields, they are transverse waves. Transverse waves meaning that the oscillations are perpendicular to the direction of energy transfer. And we know that all kinds of electromagnetic waves travel at the same speed. Light is an example of part of the electromagnetic spectrum, and so you can think of them all traveling at the speed of light. And we've already come across that in one of our calculation questions. That speed of light is 300 million meters per second, so very quick. We shorten that, if your math is very good, to 3 times 10 to the 8 meters per second to make it a bit easier to write down. Don't worry if that doesn't make lots of sense right now. Let's have a look. Now, our electromagnetic spectrum has 7 different parts to it. So try and draw this out along with me. You can pause and stop it if you need to. We have a small one in the center and then 2 lines either side to give us our 7 parts of the spectrum. Now I'm going to draw in a transverse wave at the bottom. So this end of the spectrum is going to be the part that has the longest wavelength and the lowest frequency. And as we get further along, the frequency increases and the wavelength gets a lot smaller. So long wavelength, low frequency, and on this side, short wavelength and high frequency. Oh, sorry, I just noticed that's not quite on there. That is a short wavelength. Okay. So the part of the electromagnetic spectrum, the longest wavelength and lowest frequency, is a radio wave. Okay. So the ones we listen to on the radio for music, they are the longest and the lowest frequency. Next along are microwaves. I'll try and get that so it actually fits. microwaves, what we use to cook food with in a microwave oven. After that we have infrared radiation. Infrared. Okay, infrared is what we perceive as heat. So we've come across this before in heat transfer. So infrared radiation, what we perceive as heat. That's clearly a flame. Then we have in the middle is visible light. Hopefully explains itself really. It's just the spectrum of light that we can see is in here. So all the way from red at one end to ultraviolet or violet at the other end. So you know that. Saying Richard of York gave battle in vain, red, orange, yellow, green, blue. All those different colours are within this spectrum. Red at this end and violet at this end. Our next is ultraviolet, or you would have heard of them as UV rays. So if you have sunblock, it protects from the different UV rays from the sun. So that gives you the suntan. Then we have X-rays. It's what we use to take images of in hospital. That's clearly a skeleton in an X-ray. And finally, gamma rays. Okay, these are now really small, short wavelength, high frequency. The wavelengths on these can be smaller than a subatomic particle. They can end up absolutely tiny in terms of wavelength, these gamma rays. And these are used in radiotherapy to target cells and kill them. So that is our electromagnetic spectrum. We now need to go into specific detail on the uses of those different kind of waves. So we'll start with radio waves. Write these along with me. Pause it if you need to, if I'm going too quick. So radio waves are used for transmitting television and radio signals. So they're used for both television and radio signals. Microwaves. These are used in satellite communications. And cooking food, of course. We use microwaves in satellite communications instead of radio waves because of the long wavelength of radio waves and their frequency. They actually reflect back off of the atmosphere, so they don't go out to satellites, so you have to use microwaves. Next we have infrared radiation. These are used in electrical heaters. Cooking food. So if you have a grill, then that grill is using infrared radiation to cook. And infrared cameras. So the infrared cameras are the kind of images that you get showing body heat and the sort of thing they use on police chases when it's dark at night and you can't really see people. You see those infrared camera shots of the people glowing and you can pick up where they are. Right, just make some room for the next ones. So visible light. Of course, this is the part of the spectrum that our eyes can detect and we can see, but they're also used in fiber optic communications. Okay, so this is fibre optic communications. You might have heard of in terms of broadband, so your internet connection. If it's fibre optic, then it's super fast because that signal is able to travel at the speed of light. We also have ultraviolet. As I mentioned before, this is what's used in sun tanning. So sun tanning beds, you might have heard of UV beds. And they're also used in energy efficient lighting. And X-rays and gamma rays both have the same uses. X-rays and gamma rays, so they share their uses, and they are medical imaging, okay, medical imaging, so it'd be self-explanatory with X-rays, and radiotherapy. So radiotherapy you might have heard of in the context of cancer treatments. So the cancer is just an uncontrolled mass of cells that need to be destroyed, and now gamma rays have such a small wavelength that you're able to use them to target those individual cells and kill them. So the gamma rays are used in radiotherapy. Okay guys, here are your key points from bed. We've got a few slides today, there was a lot in there. Here's the first one. Here's your second one. Make sure you've got that written down, because you do need to know what the electromagnetic spectrum is, and you need to know the order in which each different one appears. And finally, we need to know those uses. Okay, there's a lot in there to try and remember. You might want to split this over a couple of days, maybe instead of just all going for it all in one go. Maybe just learn the order first and then go on to doing the different uses tomorrow perhaps. But once you're happy that you've got all of that remembered, then move on to the practice questions. Here you go. For the last question, number 7, have a think about what type of waves they are and what you know about those types of waves. Here are your answers. Well done if you managed to get all of those. Really well done for your work on the topic so far, guys. And that's all for today.